All right, 1-4, starting 1-4, it's called Arithmetic Sequences and Series. Arithmetic is spelled the exact same way as arithmetic. So think, the word read, like I read a book, can also be I read a book. It's kind of the same idea there. An arithmetic sequence is when the pattern is adding or subtracting the same number over and over again. Okay? So you'll notice I have this recursive formula over here. I just went ahead and wrote it down as a time saver. You will want to know what that is. So first the question is the sequence arithmetic? So I look, from 25 to 20 means I'm going down 5. From 20 to 15, I'm going down 5. From 15 to 10, I'm going down 5. That's the same number over and over and over and over again. So yes, is arithmetic, because it is the same. Okay? To write the recursive, there's only two things that are going to change. It's the two that I just highlighted on the side there. The recursive definition otherwise will be the exact same for the rest of it. So see how I wrote everything else the same? A sub 1 means the first term. So what is the first term in this pattern? Oh, that's 25. Then D is what's called the common difference. So that's the number that it was going up or down by over and over again. And in this case, it was going down 5, so we say negative 5. Okay, so recursive. What about the next one? From 2 to 4 is adding 2. From 4 to 7 is adding 3. From 7 to 12 is adding 5. And from 12 to 13 is adding 1. So, not arithmetic. So, we do not have to do the top. Good job. I forgot to mention this, but it is page 26 in your workbook, if you are following along in your workbook. Let's go ahead and do knock out example 2 as well. So for the recursive definition, what is the explicit? So maybe we need to know what the explicit formula is. It is a sub n equals a sub 1 plus d times n minus 1. Notice that's a lot of the same numbers as before. And to switch forms, it's still the same thing that we need to know the difference in. So the first term is 45. The common difference, remember, is right there, so that means it's negative 2. Remember, by your order of operations, your multiplication is going to come first. So I have 45 minus 2n plus 2. Let me back up a little bit. Negative 2 times n is negative 2n. Negative 2 times negative 1 is positive 2. And last but not least, my answer here. What is 45 plus 2? That's 47. So right here is my explicit formula. Explicit to me is much better than recursive, because now if I ask you, hey, what's the 100th term in the pattern? All you have to do is where there's an n, put 100 and it would tell you. Your other option would be to start at 45 and keep subtracting 2. So 45 minus 2 is 43, 41, 39. I could do that 100 times, or I could just plug this into it for 100, which would be much easier. Okay, so you are allowed to stop there or there. I made it a little ahead of the curve, but if you look at B, it says for the explicit definition, what is the recursive? So remember, a sub 1 is the first term. and 7 is the common difference. So if I'm going from explicit to recursive, remember recursive looks like this. Where I put the first term there and the common difference there. All right, looking at example 3, what if we solve problems with arithmetic sequences? What does that look like? Arithmetic sequences are very real world. Here's an example. Samantha is training for a race. The distance of her training runs form an arithmetic sequence. She runs 1 mile on the first day and 2 miles on the second day. So if you think about day 1, day 2, day 3, day 4, day 5, day 6, day 7. Those should be evenly spaced, so pretend they are. And then you think about the space in between. There's 1, 2, 3, 4, 5, 6. 6 spaces in between. So think about that as fractions. What this means is to get from 1 mile to 2 miles, she's increasing by a sixth of a mile every day. So that means that the common difference is 1/6. She's gaining a sixth every day. Don't be scared of fractions. Okay? So your first term, which we call a sub 1, that's subscript. So like a superscript is an exponent subscript. So a sub 1 is your very first term, which in this case is 1 mile because she ran 1 mile on the first day. All right, so what is the explicit formula? So this is the explicit formula. I rewrote it over here. We also had it up here in our notes. And I'm going to take the lazy way out and erase A1 and the common difference and replace them with what the numbers are. So A1 is 1. The common difference is 1/6. Why is this helpful? This is helpful because instead of having to write out 19 days, so how far does she run on 19 days? 1, 2, 3, and you know, filling in all of those blanks to figure out on the 19th day, instead I could say A sub 19, so that's just what term, is 1 plus 1/6 times 19 minus 1. Type that in your calculator. If you're using Desmos, it will be your calculator as well, or you can download the scientific, whichever. And so it equals 4. So on the 19th day, she will run 4 miles. Okay, so something I just want to point out, if you see something that says find A sub 25, that means plug in 25 where we plugged in 19. So don't let that notation trip you up because it's actually easy what it's asking you to do. Okay, so now you try. Okay, example 4. What if I want to find the sum of the arithmetic series? So the example I love to use is an auditorium where each row has 2 more seats than the row in front of it. Do I care about how many seats are in each row? Yeah, maybe. But I care more about how many are in the entire theater. And do I really want to figure that out by counting every seat in the theater? The answer is no. So what could I do instead? Same here. The first term is 3. And then I have the 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th is 25. And it says to find the sum. What's it mean to be sum? So anytime you see the word series, it's asking for the sum. So all of these terms I would add together. Now here's what's hard. I got to figure out what those numbers are in the blank if I do it this way, like if I do it the long way. Instead, there is a formula that looks like this that will do it for me. So n is the number of terms. A sub 1 is the first term. And A sub n is the last term. So how do I use that? So A sub 12 equals 12 divided by 2. So that divided by 2 is always there. You're always cutting it in half. The first term is 3, and the last term is 25. If you're feeling lazy, just go to straight to Desmos. So 12 divided by 2, parenthesis 3 plus 25. 168. So the sum of all of those numbers together is 168. That was much easier than actually having to figure out what numbers go in between here and add them up. Now sometimes, this is when it gets tricky, sometimes they give you the first number and they tell you like how much it's increasing by, but they don't tell you the last number. So in that case, you would have to use this formula to find the last term and then plug it into there. So it becomes a two-step process. In this example, however, could I just use a calculator to straight up add that? Yep. Would that probably be quicker for most of us? Yes. So should I do it that way if it's quicker for me personally? Yes. But I will show you that the formula works. So how many terms do I have here? 1, 2, 3, 4, 5, 6, 7 terms. That means n is 7. The first term is 5, and the last term is 41. Okay, so I had to type that in real quick before I forgot it. My memory's gone. All right, 7 divided by 2 times 5 plus 41 is 161. So I challenge you to just add it up in the calculator. 5 plus 11 plus 17 plus 23 plus 29 plus 35 plus 41. And tell me, do you get the same answer? All right, sigma notation. This looks crazy. This looks difficult. It's not. It's just kind of like I've said before, math has its own language. And so if you know what it means, it's not hard. But you know, if I don't know the language, then it's hard. Sigma means sum. In fact, some books will call that summation notation instead of sigma notation. Same thing, nothing different. What it is telling you, I'm not actually going to write all this out, but it's saying that you're going to start with the first term and go up to the 13th term, where you're going to plug in or substitute in that number all the way up to 13 and then add them all together. So that sounds confusing. Let me at least start it so that you get the idea here. So if I did 3 times 1 plus 2, because that's the first term, the second term would be 3 times 2 plus 2, because everywhere there's an I, I'm subbing it in for the next number. So counting, what comes after 2? 3. And then 4. And I would go all the way up to 13. Whew, that is a lot. Now, lucky for you guys, again, we can look at Desmos. So if I look at Desmos, and you gotta remember where it is. Functions, maybe. Yeah, there we go. Okay. So on your phone may look a little different than on a computer or a Chromebook. So make sure you're looking for miscellaneous, sigma, 1 to 13. Okay, notice they used N instead of I. So I am also going to use n to keep it consistent. Look at that. It did that for me. The answer is 275. Thank you, calculator, for allowing me to not have to do all of the stuff below it. Okay. And let's see, I'm trying to decide. We'll call this the advanced problem. So if you want to figure this out yourself, you would first have to find the explicit formula and then plug everything in. And I'm going to give you like 5 seconds so that it'll give you time to hit pause if you're going to try this one. And then after the 5 seconds, I will write the answer. If you did not get that, that is okay. This is an advanced type problem, and you won't actually be tested on that problem in particular. But if you've got it, congrats to you. That's awesome. I'm so proud of you. Shoot me a message of some sort. Let me know that. And try the example, or the one that's like the last example for the week. Arithmetic series. So, real world problem. We've already done arithmetic series. Remember that was the equation that looked like this. So it says a flight of stairs gets wider as it descends. The top stair is 15 bricks across. The second stair is 17 bricks across. The third is 19. So forth and so on. What is the total of bricks used in all 16? So 1, 2, 3, like all the way down to the 16th row of stairs. Okay, so I would have to add 15 plus 17 plus 19. If it is easier for you to write all of that out and add it together, so there's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, running out of room, 16. And you just fill in all of those numbers and add them together. Have at it. See if you get the same thing that I do. Okay? For the rest of us, we need to know the last term. So again, could I fill in all of these until I got there? Yep. The answer is yes. However, if I'm going to do that, I might as well just add them all together. But I could use that explicit formula that we learned earlier. So we wrote it down a couple of times to find how many are in the 16th row. That's going to be our n. So our first row was 15, and it's going up by 2 every time. So what does this equal? So 45 equals a sub n. Now I have all the pieces that I need. I know that there are 16 rows, so 16 terms. In the first row is 15, and in the last row is 45. If you love practicing your order of operations, have at it. If you would rather just type that row in your calculator, you should get the same answer of 480 bricks were used altogether to make this flight of stairs. If you were one of those that added all the numbers on the side here, did you get 480 bricks? You should have. All right, you are finished with your notes. Make sure that you finish both targets for the week, and I will see you next.